So good afternoon, ladies and gentlemen. Thank you for being here on the second day of the meeting, and thank you for attending this. I am Vassilis Sakas, work for the IT company European Dynamics in Luxembourg, and together with my colleague Ferdinando Bosco from Engineering in Italy, we will make a presentation of a very interesting project that we concluded and some projects that we continue our first ideas regarding data spaces in the energy sector. But allow me, for 1 second, to take the opportunity, because I'm really glad to be here in Aachen. And Aachen is a very historical city. Most likely you have been a little bit around. You had the opportunity those days to walk a little bit around, and you have seen, if you are not familiar with the town, to see that it is a very old town. And indeed, there is a history, and I will connect it to Europe, because we will talk a little bit about Europe in this. So around the year 800, ruled here in Aachen, Charlemagne, Karl der Grosse in German, Carlo Magno, also very well known. And he is considered to be the first emperor, Roman emperor, that somehow unified Western and Eastern Europe. Many years later, maybe after also a Second World War, in fact, where it is also a very historical city in this regard, but it is not our case here. It was around Aachen, I mean the major area of Aachen here, Ruhr and so on, that was in the middle of the Treaty of Paris, the European Coal and Steel Community. It is what later became and evolved to the European Union that we have today. European Coal and Steel Community was a kind of an open source project by that time, in the way that we considered. And at the same year, the city of Aachen introduced the Charlemagne Prize, a prize that it is being given to personalities in Europe that promote the European idea and the European unity. And why do I say this? So, history is over. I'm not a history teacher. History is over. Why I say this? Because many years afterwards, in year 2020, we were glad to start a project which is called One Network for Europe, or OneNet, and this is what we are going to present here today. It is the project out of a vision of 73 partners all over Europe, coordinated by Professor Antonello Monti from RWTH Fraunhofer, who is also present here and is, of course, contributing to this presentation. And with a budget of 20 million euro, and almost all the European Union countries were represented here, 23 out of 27 or 28, depending on how you count them. And the vision of this was to develop some ideas, to develop some systems that for the European electricity system would provide a kind of a common, I would say, language, of a common way of operation, something that could enable stakeholders from consumers, producers, TSOs, DSOs, and so on, to communicate, to find ways to communicate, to exchange data, because it's all about data, but we will come to this later. We had too many TSOs, DSOs from Portugal to Lithuania to Cyprus, from Central Europe and so on, not to name them, all of them here, because it will take some time. We had the two European associations, ENSOE, we had a very nice presentation yesterday about SIM. We had EDSO, EU DSO was not constituted by the moment we started the project. And we created this, what we will show a little bit later. But let me make a very short introduction, what it is the challenge about. The challenge is about the digitalization of energy sector. I will not talk too much about this because we are, in fact, for 3 days, it is the third day that in this LFE meeting, we are discussing about digitalization of the energy sector. I will not go what it is and why we are doing it and so on, but I will raise one major issue. We have many things that we're discussing to do this and to do that and to do that. there are many, many other things that we don't know today. The use cases of the next day, use cases that we never thought about it. The same way that, let's say, the engineers of the 50s or the 60s were building networks, they didn't think about flexibility by that time. So the same way today that we think and discuss about flexibility, most likely we don't know what the next day will bring to us. So even the unknown is a good and interesting challenge. And it is important, of course, how we manage this information in a digital environment. Why? We can integrate all the renewables that arise. We can have demand response. We can energy efficiency. We can support the management and operation. We can have market operations or asset management. And important, a point that we consider very important, to empower the consumers. That the consumers are not something passive, but really something active on all this interaction. Of course, we have always to think a little bit about how to govern the data, so how to use standards, protocols, and so on, and consents that are in place and make things comfortable. How secure is the data? It's a big discussion. I don't think we need to make a big discussion about this. And data privacy. So not to make the data of everybody everywhere available. This is clear. Without going into many details also on this, just to explain a few words about why we like data spaces. Not only because the European Union is really supporting, you have heard of the energy data space, of this data space, of the other data space, Gaia X, for example, we have yesterday in a presentation something about this. So not only because of this, but because data space is really a very interesting approach, and especially in such a complicated environment like the European energy sector with many countries, many DSOs, many stakeholders here and there, and so on, it is something that can help and support this. Many people think that a data space is a kind of a database. No, it's not. It's a space, it is not a base. So you don't keep centralized information. You don't have a kind of a data lake, as it would be around a database. But you have the information is there, and you simply give access to it. So it is those two different ways of representation, one vis-a-vis the other. So the data space is something that has the data here and there, and you can connect to it. And you provide important functionality about interoperability, so how they can speak each other, how they can understand each other, and much more important, every participant on this has his data sovereign. It means he can control who and what can access on his data. So your data do not leave, let's say, your repository if you are not allowed for this and not to the people that they do. So it's not a discussion about data spaces themselves altogether. So the most important thing is that on this concept, we have privacy and security. So data is there, and you decide who and what, and the system of the data space gives you the confidence that you do this. Access control on that, interoperability and standards, because not all the data are of the same kind and of the same system here or there and so on. And integration and data exchange, a kind of a federated catalog where you find, where you can look and where you can find something and how you can access it. So we use the data space for our project, which will be in a few seconds presented by Ferdinando. And what we achieved, we start from the beginning, what we achieved is, if we talk about grids, better grid management. You have really a very good communication protocol and method for real-time data sharing or near real-time data sharing. You can integrate power resources like renewable resources. You can also implement energy demand response or load balancing operations. You can have to enhance the demand response mechanism on microgrids or local energy markets, because we consider that this is, of course, something that always is in parallel with the market, as the market dominates a lot of operation in the energy sector. Interoperability, and we will talk a little bit about interoperability in a while. Security, a decentralized architecture. You don't have somebody in the middle that controls everything. And of course, a nice governance framework that gives the security to every participant, that the system works the way that it is supposed to work. So much about the introduction, and Ferdinando will lead you about the technical implementation and how we follow it up in other projects.
Thank you, Vassilis, and thank you, everyone, for joining today. I would like to introduce, first of all, the OneNet Framework. As Vassilis said, we started this long journey in 2020, and we started from the needs of the energy stakeholder for designing our architecture. And the main goal is to facilitate the collaboration and cooperation among energy stakeholders without changing what was already in place, the legacy platform already in place. And the idea was to involve the energy stakeholder. On the bottom side, you can see what we named OneNet participants as participants of the data space, including any kind of energy stakeholder, operator, flexibility provider, market operator, and so on, including customer, and all the specific data sources that can be used for data exchange. In the middle part of the architecture, you can see the legacy platform, so not a new platform, but already existing platform, proprietary or open source platform, whatever is already in place, enabled to participate into the data space using the OneNet connector. That is the core building block for enabling and implementing the core concept of data space. And the middleware upon that enable the centralized part of this data space. We can say that we have two layers, a federated one and a decentralized one. I will explain in the next slide better. But the core elements, of course, are the middleware and the connector. On top, you can build your own application. For example, in OneNet, we also implemented an orchestration workbench and an analytics dashboard for improving the data space concept in the project. So as I said, the two core components of the OneNet framework are the middleware, that is the central part where you can manage all the central features for the OneNet framework, including the data space participation. So you can define the identity management, the data catalog, where all the players, all the participants can provide and publish their own data set to be shared. You can define the vocabulary for supporting the semantic interoperability of the data space and define the data access management rules and policies. The OneNet connector, that is a plug-and-play solution, so it's a very simple tool to be deployed locally, so not in a cloud or central environment, but locally close to the platform that you would like to share the data. That include the IDS components for the data space implementation. So the trust framework, the log transaction, the asset and usage control. We also included Fireware context broker for supporting NGSI LD standard and the end-to-end data exchange, and standardized open API and data application for integrating the existing platform from one side and the middleware from the other side. This is the slide that I mentioned before. I would like to spend a couple of words about that because it's important to understand the added value of this proposal, the innovation, the main innovation here. We discussed about federated layer. The federated layer includes only the middleware, that is a central instance, where all the OneNet participants can register and make the onboarding for participating into the data space. After registering your own connector, you are able to participate. You can create your own services, you can discover the catalog, you can align your own vocabularies, and so on. But the main point is the decentralized part that includes all the participants, so the network of participants. And the point is the data exchange is an end-to-end data exchange. No data are moved external to your own premises where the connector is deployed or where the consumer are providing its own connector. The data provider and consumer have a negotiation before transferring the data. that in which we can define the policy for accessing and the usage of the data. And after that, the transfer of the data is directed between the two parties that agreed on the negotiation. So no data are transferred outside of the connector premises. Another important thing for the OneNet connector, maybe you know there are a lot of initiatives, a lot of connectors that are implemented in Europe for many domains and many purposes. OneNet is the first contextualized and specified for the energy domain. We had a great work together with EDSO and ENSO-E in the project and also at WTH for creating a first catalog that include many energy services with the vocabularies included in the OneNet framework. We defined 10 categories, 64 energy services that were extended during other projects that we'll mention later. And for each of these services, we defined which are the main actors, which are the data exchanger, the data quality requirements, which are the data models and the data format that you can use as standardized for exchange this kind of data during the energy services exchange. As Vassilis introduced, OneNet is the first step, the first milestone. We started in 2020, in which we implemented the first version of the framework. We had the decentralized data space framework, IDS and firewall compliance, the standardization for the energy context. But we are continuing our journey in other research projects. Two of them I would like to mention that are very important for us. One is InterStore, that was presented yesterday in the other room, in which we evolved the OneNet connector with a new open source graphical user interface. So now the entire framework is completely open source. And we just submitted our solution within the LFE in order to be present as a project. We also used blockchain for transaction authorization. We created a new external service integration for allowing not only the data exchange in a pull mechanism, but also in a push version. And we integrated another standard that is IEEE 2030.5 to be supported directly, natively in the connector. Another important project in which we are working on is TwinEU, in which we have an important milestone where we introduced the new data space protocol that is the most used standard for the interoperability across different data spaces provided by IDSA and Eclipse Foundation. And we are working on also in the interoperability semantic level with the extension of vocabularies, supporting digital twin federation, that is the core goal of the TwinEU project. And also an important thing is increase the performance and the support to new technologies for real-time data exchange, because most of the use case need to have near real-time or real-time data exchange. So also a couple of words about these two projects. So not only OneNet, but also InterStore. For us, it's an important milestone. As I said, InterStore was also presented yesterday, so I would like to quickly recap what is InterStore project. InterStore project is a project that has the important goal to facilitate the storage facility and cross-stakeholder data exchange. And InterStore aims to provide an open source solution that is already in place and available, in case you are interested, with the 4 different open source tools. One of them is the data space connector. Others are legacy protocol converter and IEEE 2030.5 NATS integration. We tested all these tools in 9 different use cases in 4 different pilots in real field. And the main goal is, as I said, facilitated the integration of various distributed energy storage and energy resource from different energy stakeholders in an easy way, adopting data space solution. So the core that we can say here, we have the cross-stakeholder storage data from one side. From the other side, application, data-driven application that you can build using the data exchange exchanged within the data space, and all the open source toolset can be used by all the players, all the stakeholders, including IEEE 23.5 over NATS, Data Space Framework, the connector, and also additional application for data models and visualization, for interconnecting and creating new business services based on the data exchange. I would like also to report 4 example scenarios that I think can facilitate to understand how to use data space. Of course, it's not limited to that because, as I said, InterStore uses the data space in 9 different use cases and 4 different pilots. But for example scenario, in order to understand how the data exchange using data space can bring new services or facilitating new services. For example, for the battery dispatch optimization, the weather cost forecast can be exchanged for the battery operators. The green EV charging ranking, so we use EV charging data and CO2 emission for implementing a collaborative gamification. We have a service for solar PV performance analysis, in which we exchange the PV generation profile for prosumer, and another service for anomaly detection of battery storage system, in which we exchange the battery operational data for observation and comparison. Last but not least is the TwinEU project. TwinEU is comparable to OneNet because I think it's most big than OneNet, because we have now 76 partners, I think, across Europe. You can see the most known player, system operator, IT, research institute across all the main countries in Europe. It's a 3-year project coordinated by Professor Monti from Fraunhofer Institute. And we have 20 million funding from the European Commission here. The main goal of the TwinEU project, of course, is to implement digital twin at any kind of scenario and use case. We have several scenarios, several use cases that demonstrate cybersecurity, data visualization, market flexibility, and so on, using digital twin. But the core of the TwinEU project is to create the federation of digital twin, because digital twin at the moment are everywhere, integrated at any level of platform and scenario and use case. But what is missing is to create a sort of federation of digital twin where the stakeholder can exchange data for increasing the performance of their own digital twin. So creating a collaborative environment where different digital twins can cooperate for creating new business services. And the solution that we proposed in TwinEU adopted the data space for implementing this digital twin federation. The main key innovation of TwinEU project are open digital twin for grid reliability and resiliency assessment, data model and external interoperability, APC coupled federated DT infrastructure, data space adoption for creating this pan-European digital twin federation, as I said, closed loop adapted digital twin, and immersive metaverse-oriented digital twin with XR and VR visualization of digital twin. So I would like to thank not only Vassilis that is here with me, but also Professor Monti and Vincenzo, a colleague of mine that is not here today, that contributed and collaborated with us in this long journey during these 5 years. Thank you, and I don't know if there is any question.
As you have understood, we value the coffee break a lot, but before that, we have some time. So for any questions, please feel free.
Thank you. It seems like you guys have a lot of experience implementing the database concept by now, and I think one of the biggest things I hear people say is that it's complex. I guess 2 questions then is, would you agree, or is that a false narrative? And if you do agree that it is complex, do you see opportunities for simplifying the database concept so that it becomes more available to smaller communities, smaller organizations with fewer resources, et cetera?
'Cause I think, I mean, the big challenge is that, you know, the database concept is
I think the question is for me. It was for the introduction, so no problem. First of all, we don't talk about database, we talk about data space. Okay, so just, we also sometimes confuse the two things while speaking. The second point is, we didn't say that the concept itself is complex. We said that the electricity environment is complex. Yes. No, we don't. We don't. We don't. Ferdinando presented
No,
it
we
very
cannot
nice,
agree.
the federation level and the connector level. Believe me, the connector level is as simple as when you install Office on your PC. Okay, if that's your experience, then maybe I have to say the Chrome browser then. You want to say something?
No, I was saying the same thing. Let's say what our goal is to facilitate the adoption of data space. This is why we created OneNet connector. That is the solution that you can install on your own, in your own PC, very easily. And also we decided to have everything as open source because we need to have engagement. We need to facilitate the adoption of the solution because this is the entry point for creating a big ecosystem. So we believe that open source can support us on that.
And if you allow me, we have in other projects much more than the two presented here after the OneNet. We have already, let's say, packages, which we simply develop, we put in the project and they work. So you just download, let's say, somehow the software, you put it and it works.
Thank you. That very interesting conversation and talk. I work with the Trusted Energy Interoperability Alliance that is focused on the secure and attestably trustable sharing of data real time between players in the energy system. What you've presented appears to me to be quite similar in some respects, in others different. You have gone into quite a bit of depth with defining vocabularies and a taxonomy, and it's a federated approach. Our approach is more a zero trust, point-to-point, anywhere in the ecosystem, subject to a universal trust model. Just wondering if you could comment on your thoughts about those two different approaches and why, I'm presuming it seems implicitly obvious why you've taken a federated approach and data spaces approach, but in terms of securing the data exchange and ensuring its trustability, what is your solution to that issue?
For the trustability and the security, we follow the guidelines provided by DSA and the data space protocol. That is the standard protocol that you will follow for be compliant with the guidelines also in terms of trust and security. The federated approach allows you to have a central entity that certificates all the participants within the data space, releasing you an authorized certification that you can use for data exchange between the different parties. The connector itself has a tool inside that verifies the certification and the agreements, so not only the authentication, but also the authorization, so which kind of data you can access, where you can access, and so on, before any data exchange, and log any data transaction in order to avoid any problem during the data transaction. The standard that we follow that is provided by DSA has a set of rules that you need to implement to be compliant and then assure also the security layer.
Okay. And implicit in that is an ability to have all transactions fully auditable by a third party or to implement validators within the network. Is that?
I don't catch it.
So in terms of the data exchange, you described the permissions access to data, but when transactions and data occur between parties, there is defined within the architecture a way to audit and journal that, so you can have external validation of transactions. So counterparty meeting contractual or regulatory obligations, those sorts of things.
The logging is external, but all the checking is inside the connector. The two connectors are able to check and verify the policy for accessing and also the transaction of the data before and after the transaction.
Got it. Thank you very much.
Any other question? Okay, the coffee is served as far as I
Thank you, everyone.
Here, thank you very much.